the applications, that day when we started, we were discussing that, how once a concept is introduced, जैसे उस दिन मैंने बोला था कि जब सबसे पहले क्लास में एडिशन सीखा था, तो एडिशन नंबर्स का सीखने के बाद the kind of problems that we do were the word problems that you all said. Okay, so basically, when you are talking of word problems, you are actually doing nothing, but you are what we call as in technical term modeling the situation in the sense that you have a real life problem with you, okay, that needs to be solved. Like if you go back to your class, nursery, KG, or class 1 where addition was taught to you, and once the teacher taught you how to add numbers, the next kind of problems that were given to you was like, say, supposing if you have 6 apples and you have 10 apples, how many apples are there in a basket? So that becomes a real life problem. Okay, so what you did, the number of apples I have is equal to something, number of apples my friend has is equal to something, so total number of apples is this plus this, right? So what did you do? You did nothing but converted this real life problem into a mathematical problem, okay, by using whatever mathematical operations it requires to be solved. Okay, then what do? You added the numbers, you got the answer, right? Now, once you got the answer, and if you left the answer that way, I'm sure your teacher must have deducted marks. Why? Because she must have said, write the answer in the language it was asked. Like, if your result was 18, then you should have, there are 18 apples in the basket. Okay, so that means what we are doing is, we have a mathematical problem, we solve it, okay, and then we get the solution. But the solution that you get is actually a mathematical solution. Okay, the objective was to solve this real life problem. So what is required is, we translate this solution back into real life terms. Okay, so we get the solution back here. Somebody's mic is on, please switch it off. There is disturbance. So once we have the solution with us, we convert it back to real life terms, and then we write the solution also in the real life terms. So basically what you are doing is, you are translating your solution into real life terms, right? This whole process, is called as mathematical modeling. Okay, so you are making a model, which is, what kind of model is it? It's a mathematical model. You're solving it and you are giving the solution back, right? Now, the thing is that once you have the concept, उस समय तो एडिशन भी मुश्किल लगता था, right? फिर then you came across subtraction, then you came across multiplication, division, and then there were, word problems that involved all the 4 operations. So that was the tough part. Why? Because you had to decide kahan pe addition karna hai, kahan pe subtraction karna hai, kahan pe division karna hai. So as you move on, your problems that you were handling, they become more and more complex. Okay, so same is the case here that we are going to do now. We have learned the concept of, say, maxima minima, or you can say increasing decreasing function, or extreme points, whatever you want. So that means whatever we have learned about maxima minima, that now has to be used. I mean, how do we use it in real life situations? That we have to see. So that will constitute the applications of this. Some of it you have done. In fact, if you remember your class 12 book, the concept of increasing, decreasing, and maxima minima was under the chapter of applications of derivatives, right? So that means maxima minima itself is one of its applications, one of the applications of something that you had already learned, right? What was that? That was the concept of finding the derivatives. right? Now, we use derivatives to find maxima minimas, right? Then we have seen we use second order derivatives to find the points of inflections as well. And that's how we used this concept of maxima, minima, inflection, and everything in sketching the graphs, right? But then the same concept can also be used in various situations where we want to talk of, or where we want to maximize something, we want to minimize something, or we want to see what happens at what time would this be particularly, this particular thing would be maximum or minimum. So wherever we are talking of maximums, minimums, we are talking of this concept, and that's how we are going to apply it. Okay, like the very first situation, where we apply this concept of maxima minima is, सबसे पहले, see, we are all human beings. Somehow we convert everything in terms of money, right? So, like, we might be asked to maximize the profits. So that means if we are given a situation, say some store or some manufacturer, so he's manufacturing something or the other, and then they are trying to sell it. Obviously, when you are trying to sell something, you have produced something, that means there is a cost of production involved. Then you have to have a sale price for that. So that means, and then this you have learned somewhere, like cost price, you talk of cost price, you talk of sale price, and the difference between the two gives you the profit, right? But then that is when the numbers are given. Every time, if this thing cannot be in terms of numbers. So sometimes what happens is that even the cost of production follows a pattern. Okay, see, depends upon the number of units you are producing. So basically what happens is, at times the cost price can also be a function of something. Similarly, the sale price can also be a function of something. So when you have to maximize the profits in this case, so when you find, what you get is a function which is called as the profit function. And this profit function depends upon the number of units that are being sold. So that is my X. So basically I have an independent variable, I have a dependent variable, I have a function, and now I have to see when will it be maximum. Okay, so that means in this case, it's not the numbers that we are maximizing or minimizing something. In this case, we are maximizing or minimizing a function. Okay, so that is my profit function that I am maximizing or minimizing. Okay, and when you maximize or minimize a function, what concept do we use? The concept of derivatives. The same thing. So this is the situation we are going to apply this thing. I just give you a brief idea about the various situations first, and then we can talk of the so like when we talk of profit function, it has to be maximized. Similarly, I might have to minimize the cost function. Okay, because of course the cost of production has to be minimized. But then the only difference we have to understand here is that everything will now be a function. And if I have a function, that means I have an independent variable and I have a dependent variable. Okay, so that means given the situation, I have to first of all identify what is my independent variable. Okay, once I have identified my independent variable, the next thing I have to see is what kind of relationship both these variables enjoy amongst themselves. So that will define my function. So once I have the function with me, then the next thing I have to identify is what is to be maximized, the function itself or some variation in the function. Like for example, the kind of you know applications that we have is in the terms of populations, or the population could be humans, the populations could be some bacteria, the population could be some virus also. So the thing that you have to understand is, say, supposing supposing my px is the population function. Okay, that means, say, supposing I have a situation in a lab, okay, where some bacterial growth is being studied. Okay, so I have a petri dish where I have grown some bacteria, and I'm studying what is the pattern which this bacteria is following for its growth. Okay, so what I do is I observe the population, like at time t equal to 0, there are some number of bacteria in that medium. Then at time t equal to t1, after a certain interval of time, I have something else. Okay, now I have to identify the time, okay, at which the rate of growth is maximum. Now understand this. I might be, you know, asked to do this kind of a problem. Now, the moment I say at what time, basically what am I doing? I am studying the population. So that means I have a table where I have time and the number of bacteria. Okay. And based upon this table, I have a function PT, which gives me the pattern which the population of these bacteria follow as time elapses. Okay, so that means this P is a function of time. So definitely it is clear from it that my T is the independent variable and my population is the dependent variable. Problem now says, at what time would the rate of growth of bacteria be maximum? Okay, now it does not say at what time. See there, now I'm saying two different things. Just understand this. My problem can be at what time would the population be maximum, or at what time would the rate of growth be something. What do you mean by that? Rate of growth or rate of decay? What do we mean by that?
Growth by time, respect to time.
Growth with respect to time. And in
Yes,
mathematics, what do we mean by rate of changes?
time, slope,
Differentiate.
generally,
Slope or the derivatives. यही बात है
derivative.
ना?
Yes, ma'am.
So that means if I have to maximize the rate of growth, basically I have to maximize dp by dt, not p. Are you getting the point? Because if I maximize p, that means I'll find dp by dt, equate that to 0, find the critical numbers, convert them to critical points, and do whatever we have been doing. But then that will give me the time at which P is maximum. But what I need the time at which rate of growth of P is maximum. So that means I have to find P for which dp by dt is maximum. So that is not a different issue. I mean, that is not a tough issue, because instead of maximizing P, I'll be now maximizing dP by dt, because my dP by dt is also a function of time. So basically everything would be, that means my initial function or my P or my Y or my F is actually dP by dt, right? So what do? We find the derivative, equate that to 0. That gives us the critical numbers. Okay, so then we check at what number we are getting a maxima, at what number we are getting a minima. So accordingly, then we can find the solution. So that's what I'm saying. Like, this is another situation. You just have to be carefully, you read the problems carefully. Maximize या minimize किसको करना है, that needs to be identified. उसके बाद तो आसान हो जाता है, because that maths you know कि maximum point कैसे निकालते हैं, minimum point कैसे निकालते हैं, derivatives को 0 put किया है, हमारे पास आ जाता है, right? But then किसको maximize करना है, that is the crucial point. Okay, so you have to read the problem carefully and then go about solving it. Similarly, this kind of a thing is also used in when we are trying to find the concentration of drugs in human body. Right now, this concept, this application is very important in the sense that this is where actually the modeling is required. So you will be we will be studying this model in calculus. We'll be studying this model in the second semester in differential equations also. So this model is very important. Similarly, growth and decay, the rate of growth, the rate of decay, what kind of pattern do they follow, what kind of equations do we get? So they actually ultimately get converted into a differential equations that we solve. So basically differential equations also are nothing but an extension of derivatives. So जो हम calculus में अभी पढ़ रहे हैं, in the second semester it will be an extension of this, because हम second semester में differential equations पढ़ेंगे. Okay, so that's what I am just trying to explain the situations where we can model the things. Now, when we talk of concentration of drugs, now have you ever bothered, like for every medicine that we take, like there are antibiotics, there are painkillers, जैसे क्रोसिन भी लेते हैं ना, डॉक्टर says कम से कम 6 घंटे का गैप होना चाहिए before you take another crocin, right? Similarly, there are certain antibiotics that have a fixed dosage. The doctor says ये दिन में 2 बारी लेना है, but then there are certain antibiotics which the doctor says नहीं ये दिन में 3 बारी लेना है, right? So why where is the difference? Why how come they arrive at this kind of a thing for particular drugs? So that is simple mathematics behind it, and nothing more than differential equations or the concept of derivatives. How? See, what happens is when you take a drug, right? It goes, हम तो मुंह से ड्रग लेते हैं, ठीक है? It goes into our what we medically call it as gastrointestinal tract. पेट में ही तो जाता है ना, दवा जब खाते हैं तो पेट में गया, ठीक है? पेट में डाइजेस्ट हुआ, और उसके बाद थ्रू दैट डाइजेशन प्रोसेस वो ब्लड स्ट्रीम के थ्रू हमारे ऑर्गन्स में गया, जहां जहां उसको जरूरत थी, बट वो रहा कहाँ? हमारी ब्लड स्ट्रीम में, ठीक है? अब होता क्या है, every drug dissolving in the body or dissolving in the bloodstream or being there in the body itself. Okay.
Ma'am, your voice is breaking.
No, if you have basic biology, sabne padhi hai, so I'll just give you a brief intro of how this works. Because this fact is also used in if you must have, we read in the newspapers like this, for Phalana athlete failed the dope test, right? Or this athlete or this player has been debarred from Olympics or Commonwealth Games or whatever because he or she failed the dope test. Now, what is dope test? Dope test is the test to detect whether you have taken certain drugs or not, steroids or drugs, right? So that is also a drug. Okay, so whether you are taking a drug for a common influenza, whether you are taking a drug for fever, or whether you are taking a steroid, they do the same job, right? For mathematicians, they do the same job. For doctors, it's different, right? Now, that drug remains in our body for some time. Right? Now, every drug leaves a trace. Some drugs.
Excuse me, ma'am. Ma'am, your voice is breaking.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
I'll repeat now. Maybe my internet goes off and on in between. अब आ रही है?
Yes, ma'am.
Yes, ma'am.
कहाँ से ब्रेक होनी शुरू हुई थी? मैं फिर वहीं से शुरू करती हूँ.
मैम डोपिंग से.
डोपिंग से, ठीक है. Okay. Now, as I was saying, the athletes, they have to undergo a dope test to determine whether they have undertaken steroids or not before playing a particular sport. Now, every drug or every steroid remains in our body for certain time. Certain drugs leave the body immediately. certain drugs leave a trace and eventually they dissolve out. But then there are certain drugs that do not leave the body at all. Their traces still remain, even after days, even after months. So that is why the dope test has been designed. So even the dope test is able to determine any drug which has remained in your body, even if you had taken almost 2-3 months back. So that is how the test has been designed. Now the point is how it is done. How do we know when a drug is going to leave our body, right? So that actually gets modeled into a function. So basically what happens is we frame a function Cx which talks of the concentration of drug in the body, or in fact it can be a function of time also. Okay, so concentration of drug in the body, right? So as time elapses, this C of t has to decrease, right? Because initially अगर हमारे पास एक C naught amount of concentration था, like हमने कोई एक antibiotic लिया for 400 mg, so it goes into our body, it has some initial concentration. उसके बाद क्या हुआ? As time elapses, it decreases, right? So as C naught decreases, because खत्म हो गया, right? Then we have to take another dose so that we
Ma'am,
are
you
back.
were not audible. Ma'am, you were not audible.
अब क्या हुआ बेटा?
Yes, ma'am. Can you repeat from C naught?
अब क्या हुआ?
Again, your voice is not audible to us.
From C naught.
Yes, ma'am.
From
C naught.
C note.
अनन्या कहाँ से?
C naught. C naught.
C naught से. Okay. Now C naught, as I was saying, we take any drug. Say for example, when we take, as I was saying, we take an antibiotic, which is say 450 or 650 milligrams in the body. So the initial concentration is C naught, right? So as time elapses, the concentration decreases because from our, from our stomach after digestion, it will get passed on to various organs where it is required. It will have its effect, and then the concentration will gradually decrease, right? And a stage will come when it will not be in our body, right? So what do we do then? We take a second dose. So again, the concentration is enhanced, and then the process goes on. Now, this transformation, or this rate of change from C naught to 0 defines after how much interval of time should we take the drug again, because we do not want the amount of drug in our body to be more than some threshold limit. Like if I say, like जैसे क्रोसिन की बात करते हैं ना, हम बोलते हैं, डॉक्टर बोलते हैं ऑप्टिमम इज 6 आवर्स, राइट? 4 to 6 आवर्स, मतलब 4 घंटे से पहले दोबारा क्रोसिन बिल्कुल नहीं लेना चाहिए, right? Why? Because what will happen is that the drug that it has, the salt that it has, the concentration of that salt, which is paracetamol, say that the concentration of that salt will increase in our body, because जो हमने पहले खाया हुआ है अभी वो ही नहीं खत्म हुआ, उसके बाद हमने उतना ही और जोड़ दिया. So what happens is that ultimately ऐसा तो नहीं हो रहा कि हम दवा खा रहे हैं और वो डायरेक्टली उसी पार्ट पे जाके लग रहा है जहां पे उसको लगना चाहिए, नहीं, वो हमारे सारे ऑर्गन्स में डिस्ट्रीब्यूट हो रहा है, राइट? सो व्हाट हैपेंस इज दैट ग्रेजुअली अगर हम ये बहुत ज्यादा करेंगे, राइट, तो क्या होगा कि जिस ऑर्गन को उसकी जरूरत नहीं है, या जिस ऑर्गन को, या जो ऑर्गन एक पर्टिकुलर लिमिट say for example kidneys. So what will happen is that it will start damaging the kidneys then. That's why the doctors say बहुत ज़्यादा painkillers नहीं खाने चाहिए, because they have an adverse effect on your kidneys, right? Then similarly in the case of steroids, which these player takes, some of them go and enhance their muscle strength. That is why they are taking the steroids, because they want to enhance their muscle strength. या if you have heard it, जो ये होते हैं जो आजकल जिम में बहुत ज्यादा लेते हैं protein shakes, right? Now, what is the more amount of protein that you take, that goes and gets themselves deposits on their muscles, on your muscles. So what happens? Your muscle strength increases, right? But then to digest the proteins that you have taken, you have to burn them out also. So unless and until you exercise that much, that proteins will keep on depositing in your body. And what will happen? They will have an adverse effect on your kidneys. They will have an adverse effect on your heart. Now, a part of it gets absorbed in your body, absorbed in your bloodstream, and part of it gets passed out from your body, which is not required. It gets passed out of your body via your urinary tract. This is how any drug or steroid works, right? Now, the point is, I have to identify, see, all this, a pharmacist or a medical expert is going to tell you that this is the concentration function and everything else. Now, you have to tell, as a mathematician, you have to say, when will CT be minimum? Because it is when it is minimum or maximum, like when will it have an effect? After how much interval of time will a particular drug have the maximum effect? So that means we have to find the T for which CT is maximum. Okay, so that is the job of a mathematician, where you are required. So somebody has given you an equation. मुझे उससे कोई मतलब नहीं कि उसने CT कैसे लिया, नहीं, मुझे सिर्फ इस इक्वेशन से मतलब है. जब मेरे पास इक्वेशन आ गई तो मुझे तो इस इक्वेशन को सॉल्व करना है. So I'll solve this equation and tell that particular person, okay, at this particular time or after this much interval of time, CT will be maximum or whatever is minimum, or it will approach zero. See, as time passes, when will CT zero? That means you have to find T when the limit CT approaches zero. So when it leave the body, it will be totally diminished from your body. So that is what we are doing as mathematicians. Okay, so these are certain situations where we are going to model, we are going to apply the things and then see. But then, as I say, you have to read the problem carefully. Read every word of it. Informations given in the problem, none of them is useless. Everything will be used somewhere or the other. If you are not using a particular information given in the problem, that means you have not solved the problem correctly. You are committing some mistake. Okay. And the next thing that is required out of from you for these kind of problems is how you are writing them. Okay. So for that, what I would say is that for this article 4.7, what you can do is, there are 7 examples. Okay. Just read those 7 examples properly. Okay. And because I'll be doing the exercise problems, I'll be telling you how to solve a few of them so that the remaining you can do. But the solved examples which are given in the book, you have to read them to learn how to write. Okay, obviously इसमें कुछ बहुत ज़्यादा भी दिया होगा because इसने समझाने की भी कोशिश की है. But then what you have to do is read that, how to write, and then write what is required from an examination point of view. Okay, so what I feel is that in case you are going to have physical exams, again, because there is a question mark, even we don't know what kind of examination pattern are you people going to follow. In case you have physical exam, then also one problem of this type is going to come. In case you don't have physical exam, then also one problem is going to come. But the only thing is that in case you have online exam or open book exam as your seniors are having now, then solved examples for sure will not be asked in the exams. It will be an exercise problem. So दैट्स व्हाट आई एम सेइंग, सॉल्व एग्जांपल्स को पहले सिर्फ समझने के लिए और लिखने के लिए करो. जब तुम सॉल्व एग्जांपल पहले अपने हाथ से करोगे तो ही तुम्हें समझ में आएगा कि करना कैसे है, राइट? सो वंस यू हैव डन द सॉल्व एग्जांपल, then we move on to the exercise problems. Okay, now this exercise 4.7 that we have to do, I'll do a few of them so that you know how to do them. Like initial ones are easy. Let's say supposing I'm not talking of exercise 4.7. Let's see our question number 5 here. I'm not writing the problem now. Okay, I'll just write what is required. I'll just read out the problem for you. It says manufacturer can produce shoes. Okay, so that means we are talking of production of shoes here. Okay, and it says that it is done, production is done at a cost of, so we have a cost of $50 a pair. Okay, so that means we are producing shoes where it costs to produce one pair $50, and estimates that if they are sold for, so that means when we are talking of sold, it says they are sold for X dollars a pair. Okay, so this X is my variable now, which is what? The selling price, right? The consumers will buy approximately. Now we are given a function, okay? And the function is Sx. It is defined in terms of S. It says Sx equal to 1000 into e to the power minus 0.1x. Okay, now see, now this is a function of x. Okay, x kya hai? The selling price for one pair, right? So if the manufacturer sells them at X dollars a pair, then the consumers are going to buy shoes which will follow. I mean, when they are buying a shoe, of course, it's a continuous pattern. Zaruri thodi ki main number of shoes dekhungi, right? The buying of shoes, he's calculated this over a period of 1 week. Okay, so this is the function which the consumers are going to follow, pair of shoes per week, right? So that means if they are sold at X dollars a pair, then the consumers are going to buy these many shoes per week, right? The problem is, at what price should the manufacturer sell the shoes to maximize profit? ठीक है, obviously what price should he sell, ये तो हमें यहीं पे समझ आ गया था कि हमें निकालना तो x ही है, right? But we have to find x so that the profit is maximized. ठीक है, अब देखो यहां पे हमें थोड़ा सा ध्यान रखना पड़ेगा, in the sense that कि हमारे को एक पेयर बनाने में, अगर हम यहाँ पे एक पेयर की बात करें, ठीक है, तो ये कॉस्ट है और ये सेलिंग प्राइस है, ठीक है. जो हमने प्रॉफिट फंक्शन सीखा था, ठीक है, प्रॉफिट फॉर वन पेयर, because everything is given in terms of a pair, right? So profit for one pair is going to be how much? Selling price minus the cost price. यही होगा ना, ऐसे ही निकालते हैं, ठीक है?
Yes, ma'am.
But then this is for only one pair. अब ये जो आया, इसने हमें क्या दिया? सेल किसका? शूज का. कब? ओवर द होल वीक, राइट? इसका मतलब अगर वो एक पेयर ऑफ जूता बेच रहा है तो वो इतना प्रॉफिट कमा रहा है एक हफ्ते में, बट एक्चुअली में वो कितने पेयर्स बेच रहा है? इतने, एक हफ्ते में तो वो इतने पेयर्स बेच रहा है ना. सो दैट मीन्स इफ आई से द प्रॉफिट for 1 week, then it will be nothing but the profit one pair into the number of pairs sold. यही तो प्रॉफिट 1 वीक में आएगा. बट उसने पेयर्स बेचे कितने जो ये फंक्शन फॉलो कर रहे हैं? दे आर नॉट नंबर्स नाउ, दे आर नाउ फंक्शंस. तो ऐसे ही निकालेंगे ना. एक पेयर ऑफ जूते पे उसको ये प्रॉफिट मिला. सपोजिंग उसने 10 पेयर ऑफ जूता बेचा तो उसको कितना प्रॉफिट मिलेगा? x माइनस 50 इंटू 10, राइट. बट एक्चुअली में उसने एक वीक में कितने पेयर्स ऑफ शूज बेचे? sx. So basically this will be nothing but x minus 50 into sx. So basically your profit function for this particular problem, your px is actually nothing but x minus 50 into function क्या था हमारा? 1000 into e to the power minus 0.1x. Now this is your profit function. Okay. So now हमें maximize किसको करना था? Profit को ही. So we have to find x for which p of x is maximum. ठीक है. वो कैसे निकालोगे? We find p dash x. Right? We'll find p dash x. We'll equate that to 0. And then इसके आगे कर लोगे या मैं बताऊं? क्या हुआ? मैं गायब हो गई थी क्या फिर से?
हम कर लेंगे.
इसके आगे कर लोगे
यस मैम.
या कर रहे हो? अभी क्या कर रहे हो? मुझे कुछ तो बता दो.
मैम कर लेंगे.
कर लेंगे. ठीक है.
Yes,
सो
ma'am.
कैन आई मूव ऑन नाउ?
यस मैम.
Okay, let's see, like for example, हाँ, ये ले लो. Question number 8. This is regarding the population, जो मैंने second example दिया था. It says that it is estimated that t years from now, the population of a country, okay, so we are talking of population of a country now, okay. So t years from now, the population of a country will be given by 160 upon 1 plus 8 e to the power minus 0.01 t. Okay, this is how the population is going to behave. Okay, this many million. After t years, this will be the population of a country. The problem is when will, I'm writing, it says when will the population be growing? Now see, the population be growing most rapidly. Okay, now you understand the problem. It does not say when will the population be maximum. The problem says when will the population be growing most rapidly, right? So maximum किसका करना है?
रेट मैम.
Rate. I am back, girls. Sorry. So we are talking of the most rapid growth, right? Population be growing most rapidly, right? So that means we have to maximize the rate of growth, not the population, but the rate of growth of the population. Okay, so what we have to do is we have to find p dash t first. Of course, it will again be a function of t. कुछ ना कुछ तो आएगा यहाँ पे, ठीक है? And then you have to maximize p dash t. That means you have to find t when p dash t will be maximum. Is this clear? That's what I'm saying again and again. Read the problem carefully. क्या निकालना है? It all depends upon that. Okay? कर लोगे?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. उसके बाद देखो ये वाला जो इसमें क्वेश्चन नंबर 11 है ना, just look at question number 11 and 12. They use certain concept which I'll just tell you. अभी मैं आज ज्यादा नहीं कराऊंगी. Where is my cursor going? I won't do much because I've given you 7 examples and then I'll give you a few problems, not all. Now just look at question number 11. Now it says the total cost in dollars of manufacturing X units of a certain commodity. So we are given a cost function as 3x squared okay. Now there are 3 parts to it. You do the first 2, it's okay. Baki ka C part agar chhod bhi doge to not an issue. It talks of 2 terms in the first 2 parts. In the first part, level of production is the average cost per unit, average cost per unit, and it talks of another thing, the marginal cost per unit. Now, is there anyone from commerce background here or somebody who had studied economics in class? Yes, सारे बोरिंग हो फिजिक्स केमिस्ट्री वाले.
मैथ्स.
हाँ अनन्या, क्या पढ़ा था आपने? इकोनॉमिक्स?
नहीं मैम, मैथ्स.
हाँ, एनीबडी? कोई नहीं जिसने इकोनॉमिक्स पढ़ा? सबका फॉर्म खोल के देख लूंगी मैं, तुम्हारी मार्कशीट्स. हाँ, और जिसने पढ़ा हुआ उसको पकड़ लूंगी. किसी ने नहीं पढ़ी इकोनॉमिक्स?
No, ma'am. Ma'am.
नो मैम.
तभी तो कह रही हूँ सब बोरिंग हो फिजिक्स केमिस्ट्री वाले.
No, ma'am. No, ma'am.
अच्छा, फिजिक्स केमिस्ट्री बोरिंग नहीं है, इंटरेस्टिंग है.
Economics.
यस मैम.
Yes, ma'am.
Yes, ma'am.
ओके, चलो लेट मी
Ma'am,
कम.
मेरा था.
हाँ क्या बेटा, क्या बोले बेटा, फिर से बोलो.
Ma'am, मेरा economics था.
अफरूजा का. ओके, तो फिर बताओ एवरेज कॉस्ट क्या होता है, बता सकते हो?
Ma'am, total cost. Ma'am, marginal cost तो total cost. हम उतने अच्छे से याद नहीं.
ओके, आई विल टेल यू. चलो सिंपल, इसको याद भी ऐसे ही रखना. एवरेज कैसे निकालते हो?
टोटल अपॉन नंबर.
Total by number.
टोटल अपॉन नंबर. ठीक है,
Number of two.
टोटल अपॉन नंबर. ठीक है, अब इसमें हमें एवरेज किसकी निकालनी है? कॉस्ट की. ठीक है, बट कॉस्ट क्या है? फंक्शन. फंक्शन किसका है? एक्स का. ठीक है, तो इसका मतलब x, अगर हम इसको अपने दिमाग में याद रखने की कोशिश करें तो x एक तरह से हमारा नंबर हो गया और cx क्या हो गया? कॉस्ट हो गया, तो एवरेज कॉस्ट विल बी गिवन बाय C by X. ओके, ये होती है एवरेज कॉस्ट, टोटल अपॉन नंबर. वही लॉजिक है, कुछ नहीं यूज किया. बट इस केस में क्योंकि हमारे पास नंबर नहीं है, लेकिन नंबर की जगह हमारे पास क्या है, जो चीज, C इज डिपेंडेंट अपॉन X, ठीक है ना. कॉस्ट इज डिपेंडेंट अपॉन X. X क्या है, नंबर ऑफ यूनिट्स प्रोड्यूस्ड. तो जैसे जैसे नंबर ऑफ यूनिट्स चेंज होंगे, ऐसे ऐसे हमारा C भी चेंज होएगा. तो इसलिए एवरेज कॉस्ट क्या हो जाएगा, C अपॉन X. ठीक है. एंड जो मार्जिनल कॉस्ट होता है, मार्जिनल कॉस्ट इज द, मतलब कॉस्ट का मार्जिन एक तरह से देखा जाए, which is nothing but the derivative of the cost. Okay, so marginal cost is dC by dx. Okay, अब जैसे क्लास क्वेश्चन नंबर 11 में कॉस्ट की फंक्शन की बात कर रहा है, क्वेश्चन नंबर 12 में वो रेवेन्यू की बात कर रहा है. ठीक है, तो चाहे हम कॉस्ट की बात करें, चाहे हम रेवेन्यू की बात करें, जैसे हम एवरेज कॉस्ट, मार्जिनल कॉस्ट बोल रहे हैं, ऐसे ही वी कैन टॉक ऑफ एवरेज रेवेन्यू एंड मार्जिनल रेवेन्यू. ठीक है, एवरेज रेवेन्यू क्या होगा, रेवेन्यू फंक्शन अपॉन एक्स. मार्जिनल रेवेन्यू डेरिवेटिव ऑफ रेवेन्यू विद रिस्पेक्ट टू एक्स. अब याद रहेगा. ठीक है. नाउ the problem says at what level of production is the average cost per unit the smallest, and the B part was at what level of production is the average cost equal to the marginal cost. ठीक है, तो ये sorry, this was the B part where they were to be equal. That means you have to find X for which AC is equal to MC. निकल आएगा, right? In the A part, you have to find X for which AC is minimum. हो जाएगा अब. ठीक है. Similarly, question number 12 में you have to do it for the revenue functions. Okay. I won't continue further. I'll stop here because I know you have next class. But what I want